We often dream of traveling through time. Imagine stepping into a machine and journeying to the past or future. Picture witnessing historical events firsthand, or envision venturing into the distant future. Think of witnessing humanity's advancements. Time travel has fueled countless science fiction stories, from H.G. Wells's The Time Machine to Doctor Who and Interstellar. These stories often touch upon real scientific concepts. They spark our curiosity about the nature of time. Why does time seem to flow in one direction? Could we ever manipulate its flow? Understanding time is crucial for our existence. Time is the fabric upon which our lives are woven. It dictates the order of events and shapes our reality. Is time travel merely a fantasy, or could it be possible? To explore this, we must delve into Einstein's theory of relativity. Albert Einstein, through his theory of relativity, unveiled a profound truth. Time is not absolute. Time is relative, affected by gravity and motion. This concept, known as time dilation, is a key outcome of Einstein's work. Imagine two identical clocks. One stays on Earth, the other travels through space. Upon return, the traveling clock shows a different time. Gravity also affects time. Clocks near massive objects tick slower. These concepts are experimentally verified and crucial for technologies like GPS. Could we potentially exploit these principles of relativity for time travel? Some physicists believe that wormholes, hypothetical tunnels connecting distant points in space-time, could offer a shortcut. Imagine folding a piece of paper and then poking a hole through it. The hole acts as a shortcut, connecting 2 points on the paper that would otherwise be far apart. Similarly, a wormhole could potentially connect 2 different points in time, allowing for travel between them. However, the existence of wormholes remains purely theoretical. Even if they exist, their stability and our ability to traverse them are significant unknowns. Another theoretical concept is that of closed time-like curves, which are essentially paths through space-time that loop back on themselves. These curves, predicted by Einstein's equations, suggest the possibility of traveling through time by following these loops. However, like wormholes, closed time-like curves remain firmly in the realm of theoretical physics. Section 4. Paradoxes of Time Travel, Untangling the Possibilities. The concept of time travel often leads to intriguing paradoxes, the most famous being the grandfather paradox. Imagine going back in time and accidentally killing your grandfather before your parent was born. This action would seemingly prevent your own existence. But if you never existed, how could you have traveled back in time to kill your grandfather in the first place? These paradoxes highlight the potential logical inconsistencies that arise when we contemplate altering the past. Some physicists have proposed ways to resolve these paradoxes. One idea is the Novikov self-consistency principle, which suggests that if time travel is possible, the laws of physics would somehow conspire to prevent any action that could alter the past. In other words, you might be able to visit the past, but you wouldn't be able to change it. Another perspective is the many worlds interpretation of quantum mechanics, which suggests that every quantum measurement or decision creates a new, parallel universe. In this view, traveling back in time might lead to a split in the timeline, creating a new branch of reality where changes occur without affecting the original timeline. Section 5. Time Travel, Science Fiction or Future Reality. While the possibility of time travel is a fascinating area of exploration, it remains highly speculative. The scientific community is far from a consensus on whether time travel is truly achievable. The challenges are immense, and our current understanding of physics may be incomplete. However, the pursuit of understanding time travel is not futile. It pushes the boundaries of our knowledge and forces us to confront fundamental questions about the nature of reality, causality, and free will. Perhaps one day, what we now consider science fiction will become science fact. Until then, the mysteries of time travel will continue to captivate our imaginations and inspire us to explore the furthest reaches of our universe and beyond. So, I leave you with this question. If you had the opportunity to travel through time, where would you go and what would you do?